I'm all wired up. Can you hear me just fine? Not too loud? Okay. All right. Well, let's see how this works. Yeah, thank you for coming. I want to thank big thanks to Lowell Observatory for hosting this event and others, and a big thank you to all the people who work on the Festival of Science. It's a great institution. So, harvesting new knowledge from spacecraft data. Brandon's already kind of told you a little bit about what I do, but there's some pretty pictures. I'll throw in something that I like to brag about. As much as working on those other projects, those space missions was a lot of fun. This was one of the fun times in my career. This is the NASA, we call them the Research and Technology Studies Group, or shortened RATS. They were looking for a place to do a spacesuit test in preparation for either future lunar missions or Mars missions. So I recommended this area out by Grand Falls. So they invited us to be in this picture. And I want to say this is my claim to immortality, my one and only claim to immortality, because it's an actually, it's actually official NASA photo. That's me up there. I'll just point out real quick, this fellow Rick Balch, a videographer from down in Sedona, because I'm going to talk about him just a little bit later. Okay, getting to today's topic. This is the Surveyor spacecraft. Looks like a lot of people in here probably remember Surveyor. It was the United States' first soft landers on the moon prior to the Apollo landings. And so a lot of you might have seen these pictures, maybe in Life magazine or something, of a picture taken by the on the surface of the moon. The thing I want you to notice here is all the little pieces, all the little patchwork look to the image. It's because the Surveyor took very small little pictures, and they're kind of pasted together, literally, as I'll show you. Quick summary on Surveyor: 1966, 1968. There were 5 successfully landed. I like to always brag on Flagstaff's Gene Shoemaker. He was the chief experimenter for the project. Surveyor took like 11,000 pictures. You can see in that mosaic where there are so many pictures. This is Surveyor crater on the moon, taken by the Apollo 12 astronaut. The lunar module landed on the rim of Surveyor crater. It was a test to see how close they landing, which was instrumental in future missions. I want you to notice here, right here, you see a little something down in the crater here. That's the Surveyor sitting there on the surface. Okay, I mentioned Gene Shoemaker was the chief TV experimenter on there. A little piece, I'm going to do a little bit of local history. Surveyor television experiment field test number 2 occurred out here in just the Sunset Crater. They did a test out here, one of several tests. This shows the, you can see a boardwalk. This is on the Bonito lava flow out at Sunset Crater being at the top in the background. They had to create this boardwalk to get equipment out, and even at that, they had to create a rig to lower the equipment down where they needed it because it was such a rough flow. This is a still frame taken from a movie that I was involved in helping save. Just want to point out here that they're installing, these gentlemen are installing, that's Elliot Morris, Ray Batson, some locals. They are installing the Surveyor camera on a tripod mock-up of the lunar, of the Surveyor lander. Here's a wider picture. So you see the mock-up sitting there. You see the equipment down here, and here's this kind of rig to get some of the equipment down to where they needed it to go. All right, these were also taken from some 16mm movies that were taken at the time. What I want to point out with these pictures is, I want to explain a little bit, is you can see there's a pin axis here. This is an oval mirror. So that mirror was sticking up, doing this, and what it would do is it would tilt. It would tilt in steps. There's also right here, it rotates on this arm. So the way it would get these mosaics is by tipping, moving, moving. So that explains the crazy quilt work in the pictures. So there it is out on the Bonito Flow out by Sunset Crater. And this is Al Bean at the actual Surveyor 3 spacecraft that you saw in that crater picture before, lunar module at the top of the frame there. Bean actually removed the camera and brought it back to Earth, and I believe a local, another Flagstaff local, Hank Holt, looked at that when it was brought back. Okay, so here's an example of mosaics taken by the surveyor out at Bonito Flow. On the left is using the narrow angle mode of the camera. On the right is the wide angle mode. So that's why it's easier to see detail, and you can actually, the picture on the right is a lot easier to look at. The trade-off with the wide angle is you don't have the detail. But remember, this is back in the 1960s, and that's the way they did things. And let me explain a little bit about the mosaicing procedures that were done at the time. So, literally pasting photos together to put these mosaics together. And in this case, notice the person is using a stapler. So low-tech mosaicing back in the 60s. One of the things I did during my career was doing digital mosaicing. So this is kind of interesting to look at. Here's an example. Rather busy, kind of hard to see, you know, really if you're trying to analyze this, it's really hard to make sense of it because of the mosaicing. Here's an example a fellow named Gary Reynoldson did a number of years ago using one of the surveyor mosaics, where he basically did some modern image processing and removed a lot of the noise from the mosaic. Now, the thing is, this picture looks nice. It's aesthetically more pleasing, but do we really can we really get any more information out of this? So let's look at, this is going to be the Surveyor 7 target area. And oh, before I go on, I should shout out to Ray Jordan here. He worked on the Surveyor project. Sitting up here, an old friend of mine. So Surveyor 7 landed on the rim of Tycho crater. Are any 2001 Space Odyssey fans in the audience? Or at least have seen it? TMA1, remember that? Where the monolith was? Stands for Tycho Magnetic Anomaly 1. So, and by the way, 2001 is showing out at Harkins tonight if you want to see it. Just coincidentally, I didn't arrange for that. Okay, so this is a picture from the Surveyor 7 on the rim of Tycho in the old mosaic format. Here's a reprocessed version of that. Now again, a lot prettier looking, but you know, really, is there much more data in here, or is it just, you know, a little more pleasing to the eye? So back again to the old one. And now I'm going to zoom in. We're going to zoom in on this outlined area. Look at that. It's almost like an entirely new image. I'll back up real quick so you can see the difference in that. It looks like a picture taken by the Apollo astronauts on the surface. All right, this rock over here. Let's, that rock right there, I'm going to move front and center, and we're going to zoom in on that. Or take it back, not quite yet. So they're back to the original image, and you can see the amazing difference in the data that's there. It makes it a lot more interpretable. But let's look at this rock that's in the foreground, as pointed out by the arrow. That's the large rock down here at the bottom. Okay. Now, there's a rock in the newly processed image, but the rock I'm showing you in the inset is not this one here in the foreground. It is that rock back there. Yeah. Now, let's look at this rock in the foreground. Look at the difference there. What's interesting here is where in the old photo, basically it was black. Let's say you processed it a little differently in the photo lab and brought out some of that detail in the shadow, but nonetheless, you can see a lot more detail in this newly processed image. And what I want to point out here, in the interest of actually interpreting things and not getting too much into the geology, is look at these shapes here, these polygonal shapes in here. These are probably, I would interpret them as large crystals. Okay, large crystals tend to form at great depth. You also look at this crystalline area. It's in a matrix. It seems kind of darker and seems to be defined by about where I'm showing there. So these are what geologists would call, if my interpretation is right, they're called phenocrysts. So the block that they're in would be called a xenolith. It's a rock that was ripped up on the way of either magma moving up to the surface or perhaps being coated in what they call impactite, in other words, impact melt. So the block, we can now possibly interpret it as being ejected from probably Tycho crater. And we can see that maybe this would be, if we were to go back there, we might want to go to this boulder and sample this because of what we've seen from here. Okay, summarizing the surveyor data. The restoration for this was done from film negatives, but not the original downlinked data. By downlinked, I mean the data that was sent, telemetry radio signal back from the moon. And we saw that, we could, well, we will, I'll show you, we can get more information if we had the original downlink data. So let's take a look at an example of that. This project was done about 15 years ago, Lunar Orbiter Image Recovery Project, or I'll call it LOIRP for short. It's not a whole lot shorter. And a rather amazing project this was. Real quick recap, Lunar Orbiter, there were 5 missions, orbited the moon from 64 to 68. It was done, it did preparatory mapping of nearly the entire moon. A lot of it was focused on looking for landing sites for the Apollo missions. All right, with this nice big screen that Lowell has here, I think you can see a lot better than my home screen at the difference between the original and the reprocessed stored data. But it's even hard here to tell. Oh, this, by the way, is the first photograph of the Earth taken from the vicinity of lunar orbit. So it was very special, and they had to really argue hard to get them to reprogram and get this picture. Again, reprocessed on the bottom, original on the top. Now, if you think this is impressive, let's zoom in on this area. Okay, it almost, you have to look at it for a little bit to see that it's even the same image. So, and let's do one more. Let's zoom in yet again. Look at that. Now, my friend Ray Jordan here in the front row said, am I going to bring up Keyhole? Lunar Orbiter was based on military spy satellite technology at the time. And if you're aware, at the time, they would actually have film on board these spy satellites. They'd take actual photographic film, and then they would drop it out of orbit. An airplane would fly by and scoop it up in midair. It's kind of an interesting story. Okay, so backing up, here we go. Here's that zoomed in area from this reprocessed photograph. Here's a shot looking back at the moon. Top one's the original, lower is restored. The people that did this found they got 4 times the dynamic range out of the restored data. You can also see there's also an increased definition in terms of resolution and detail that you can see. Okay, so I just mentioned this film was processed on board the spacecraft. The spacecraft orbit eventually decayed, crashed into the moon. So we don't have what's technically called the first generation data that was acquired. This is what we get back on Earth after they were radioed back to Earth. This is a mosaic made up of a bunch of little strips. The film on board was 70 millimeter, rather large format. And I'll show you, it's kind of important. Don't get too bedazzled by all the detail. But what I've shown here, or I'm sorry, this is somebody else's graph, up in the upper left corner here, shows film supply, loads the film of the moon over here. It would be scanned, and it would be sent from the spacecraft down to Earth receiving dish, recorded on a receiver on magnetic tape. So in the original process, like the mosaic we just saw, the next step would be to go to here. Kinescope, for those who may not know, kinescope is where you basically point a camera at a TV screen, a CRT screen. If there's any young folks in the audience, a CRT screen may be ancient history to you. But it involved vacuum tubes and electron beams, and it wasn't super great. So what they did was they pointed a camera at a TV screen, recorded the film, and they printed out these 35 millimeter strips. You saw how that was that mosaic was very striped. Then they would take a picture of that. They would mosaic it together, take a picture of that. That's what we saw on the last screen. And then people would work with this. So you're several steps away, several generations away from the original data. Here, 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 and then here. Now, what if you could go back? Well, in fact, the LOIRP people did. They went back to the telemetry data. You mentioned that. Oh, just the fact that the tapes were almost thrown away in this case makes it all the more interesting. But keeping the data is only half the problem. What if you don't have something to read the tapes? Kind of makes them useless, right? Okay, this mission was in the mid-1960s, and we all know computer technology, it just moves along at a rapid clip. Well, they threw away the data. They threw away, I'm sorry, the equipment that could read it. This is a woman's garage. She couldn't bear to see the equipment thrown out. So she collected these tape drives and some other equipment, kept them in her garage for many years. So there's some guys here, moonviews.com, I think they're still up. You can go there and get some more of the history. They had this idea to go back and look at these tapes and reprocess this stuff. Here's a close-up of the stuff in our garage. Now here's the tapes that I mentioned, nearly got thrown out, but somebody put their hand up and said, hey, maybe we shouldn't do that. They didn't. So I mentioned these guys decided to preserve the data, and they set up shop in this abandoned restaurant. Unsurprisingly, the project got the nickname McMoon. All right, now, some of the other equipment they found in a chicken coop. Now, as Steve Jurvetson of the LOIRP points out, that there's only one person on Earth who still refurbishes these tape heads, and he's retiring this year. Now, this was about 14 years ago, or well, actually, more like 20 years ago when they started the project. The skills to read this data archive are on the cusp of disappearing forever. That's an important point that I'm going to come back to in the talk. The equipment you can see here set up inside this restaurant. This is Dennis Wingo. Deserves a whole lot of credit for initiating this project. Another view of their setup. Okay, let's get to why should we bother? It's old spacecraft data. We've got newer. We've got Lunar Reconnaissance Orbiter, and maybe more data now. Well, here's one reason. It allows us to go back in time, so to speak, to the mid-1960s and see what the moon's like, what the moon was like back then. But you might say, well, it's a dead body. Why do we, it's not going to change. Well, actually it is. It may be all but dead, but, there's actually data to be learned from this. So one of the things it does for us is it helps us refine the impactor flux. You've all seen shooting stars probably. Well, there's bigger objects, and the moon's a pretty big body, and it's getting hit by objects all the time. It also allows us to look at study of impacts. If you can look at the moon back in the 60s and you see a new impact on the new data, we can look at how what kind of the geomorphology, if you will, of the impacts and the impact process. It also tells us a little bit about where it hit on the moon. Is it a deep debris layer, or is it solid rock, or what are we looking at? We can tell a little bit about that. I mentioned the Lunar Reconnaissance Orbiter. This is an image from that on the right. If you want to go to this website, you can actually participate. They have so much data, they're asking people to go and help. Look at some of this Lunar Reconnaissance Orbiter data, compare it to the Lunar Orbiter data, and see, in this case, the area that's outlined here shows a new crater that's formed since the 1960s. It's got a really long URL. I wouldn't suggest trying to memorize that. Just Google moon diff. Okay, so lessons to be learned. Now, this was 35 years after the mission. And one of the things is that our image processing technology has gotten better. Our computers have gotten a lot faster. People are writing smarter apps. So reprocessing the data is like getting a whole new mission to the moon for very little cost. Because even basic missions, hundreds of millions of dollars. I mentioned it's kind of like giving us a time machine to look back at the moon 60 years ago, and gives us a good idea on impact rates in the Earth's neighborhood. All right, let's change and we'll look at a different data set. Apollo. Each mission set up a seismometer on the moon. This is Apollo 11 seismometer. So there were 6 seismometer stations set up. They left them operating until September 77. I think, unfortunately, they stopped because of budget cuts. The equipment, I think, was still operating. I want to show this one, Apollo 17 in the Valley of Taurus Littoral on the moon. This is the seismic station here in the lower right. This was set up by Flagstaff astrogeologist Jack Schmidt. Okay? First and only geologist to do geology on another body in the solar system. Okay, so here's some data. Truthfully, I don't know how to interpret seismic data. I've got a couple hours of it in my education, but the top 4 seismograms are from the moon. On the bottom is a typical Earth seismogram. They look a whole lot different. They were unable to interpret this. They were so different, they didn't know how to interpret this data. Now, as I mentioned, this isn't my field, so I'm going to let NASA's chief scientist, Jim Green, explain it. So they were able to see evidence that the core is divided into a fluid outer part and a solid inner part, and see a distinctive layer above the outer core. Well, that means a lot in terms of people that study the evolution of planetary bodies. All right, let's quick look at a couple of examples from the Apollo rocks brought back. This again is Jack Schmidt with his rock hammer there, sample bag here, rock hammer there. Just want to point this out. If you've looked at Apollo photographs, you'll see this in a lot of pictures. Called a gnomon, and it was developed here in Flagstaff. Again, another link to Flagstaff history. Okay, I'll let you read that while I'll tell you. Basically what they did when they got the rocks back from the moon, they were wise enough to set aside about 25% of the samples, just thinking that in the future, they didn't know when we were going to go back to the moon again. So they set aside a number of samples. I think there's about 800 pounds brought back, so that indicates they saved about 200 pounds, anticipating that this technology would advance to where they could do science with these pristine samples in the future. Here's one of the things that that's come up, fun thing to go to online. It's called NASA Astromaterials. I'm going to stop doing that. 3D Explorer. So if you want to go online and play with this, what they did was one of the technologies that has come about since the 1969, 1972 time period is computer tomography. So here's a rock sample on the left. You can go into this app and go in and press these slider buttons and move the cut so you can look at this in 3D. Now you say, okay, that's kind of gimmicky. What good does it do us? Well, it allows us to do what engineers would call non-destructive testing in a sense. We can look inside, like if they did a CT of your body, you can look at the organs, and they have special ways of looking at that. So if there's a little inclusion, something like that, you could look at it in 3D, and that could tell you something. The other useful thing this allows you to do is to, when you can see it, if you're going to slice up this rock and hand out samples, you may want to make your cut in a different position. All right, this is an example of geochemistry, example of things that have been learned since the Apollo missions. In this case, it was investigators from ASU and the University of Chicago. And based on samples and some of the analysis they've done, again, with more recent techniques, is they've determined that they believe they can say from this sample using their geochemistry that the moon forming impact occurred about 150 million years after the Earth itself had pretty much coalesced. And they think, I don't know how they can do this, but they also think from the data that they can say that the moon cooled relatively quickly after that impact. It took about 20 million years to cool. So again, these are important things to geoscientists, of passing interest to some people, but nonetheless, this shows some examples of the changes. So what's the lesson of all this? Again, if you don't preserve the data, you don't, keep some of the rocks aside, you can't go back. Okay, now brings us to what I consider one of the most famous cases of lost data. Okay, how many of you recall this fiasco? All right. Again, I think most of you know, I think this is what they might call a meme today, this Michael Jackson doing his moonwalk or whatever. So just, okay, so lost Apollo tapes. All right, some headlines from the 2000 aughts. I'm sure a lot of you remember this. It was a big to-do over a couple of periods, both in about 2006 and then again with the Apollo 11 50th anniversary came up again as an issue. All right, now it's not like you figure somebody would have had to tell NASA to keep the home movies, right? I'll let you read this one. Michael Collins, of course, being, if you don't know, he was the command module pilot who flew Buzz and Neil to the moon and back, okay? And was up in orbit by himself. How many of you have seen From the Earth to the Moon series? Oh, you need to see it. It's great. It's an HBO production. It was based on Andy Chaikin's book, A Man on the Moon. And just, let's see what we got here. So Andy was out here in Flagstaff, and I'll explain how I got a hold of some of the Apollo moonwalk tapes in just a little bit. But Andy told me that Buzz Aldrin did not have video of his own moonwalk. He asked me to send him a copy, and I sure did. So I made him a special case and sent him this. And in return, he signed a picture for me. At any rate, so getting back to the topic of the talk, why is the downlink data so important? Well, as we saw with the earlier example, it is important. It makes a huge amount of difference. We have a clock in here. I want to kind of watch the time. Okay. All right, so I'll walk you through the Apollo TV. So the TV data was beamed back from the moon. Okay, this picture here came from Goldstone, which, as many of you know, is out in the Mojave Desert, a few hundred miles west of here. This image, a lot better, came from Honeysuckle Creek, which is in Australia. Now, quick story. If you've seen, I don't know if it's in the movie The Dish, but what happened was they found that Goldstone was having problems, so NASA quickly switched to Honeysuckle. Then, for reasons I think that the Honeysuckle still wasn't quite as good, and they found out that Parkes, which is also in Australia, the Parkes radio dish, had a better signal. So they again switched to that. This was in the very first couple of minutes of the broadcast. This is a picture of the Parkes dish. That's me down there. All right, now this is something that I think a lot of people are not aware of. They did not plan for having a TV transmission from Apollo. Believe it or not, they did not plan for TV. There was a bit of a fight about that. They finally went ahead and got a TV on board, but here's the problem. Because they hadn't planned for it, there's only a certain bandwidth that they could transmit back from the lunar module back directly to Earth. So they had to create a new television system that could use that little available bandwidth. In other words, how much data can go through that stream. So what they did in order to do that, they developed what was called slow scan. Okay, this is a picture taken off a screen at one of the receiving stations in Australia, I believe. Oh, it says Honeysuckle. You can see how good that picture is. Let me explain what slow scan is. Oh, and by the way, this is an excellent documentary if you can find it, if you have any interest, Live from the Moon. It's a fantastic documentary on that issue. Okay, so slow scan. What's slow scan? What they had to do was typical, even an old 8mm handheld movie camera was like about 18 frames per second. Today's video, I think, is about 30 frames per second. They had to basically slow down the transmission to 10 frames per second. Very slow. Now, that would not broadcast out to the world at 10 frames per second. So they had to run it through this slow scan processor and create what's called, at the time, NTSC, television standard signal for broadcast. Okay, so here's an example. Let me jump to the next one because it's actually better. This is a blow-up of those previous pictures. On the left, again, some of the people at the ground stations just went up there, sometimes with an 8mm film camera, sometimes a Polaroid, as in the case on the left here, and just took a picture off screen as they were getting it. So this was the slow scan version. On the right's the NTSC conversion. I think you can see, especially again on this big screen, the difference. I'll point out a few. You can actually see the lunar module leg here, and this is Buzz Aldrin's faceplate. You can see Neil Armstrong's reflected, his head, his life support system on his back, his torso, his legs. On this side, after the NTSC conversion, it's a blob. You couldn't really do any interpretation from that. So also keep in mind with this student taking a Polaroid off of a CRT screen, that's still 2 generations away from the original down data that was sent down. I put this in because it tells us something else that we can do as far as image processing. This confirms the fact that even though the signals might not have all been, one signal was best, but 3 stations were downlinking the data and should have had tapes. So when NASA lost those tapes, they didn't lose 1 set of tapes, they lost all 3 sets of tapes. And had we had those 3 sets of tapes, you could have combined them, and in doing so, you could have enhanced the signal to noise ratio. In other words, gotten a lot better picture. One thing I didn't mention in the last photo is a lot less noise in the background, a lot less streaking and noise. Okay, see if I have time to do this. Anybody remember this story? Let me tell you, this guy sold these tapes, these 3 tapes for $1.8 million. He paid 60 cents in a NASA surplus sale for these 3 tapes. Best purchase ever. Not quite, not quite. I'll explain. Oh, I'll tell you, since you bring it up, not quite. These were still not, but the lost tapes are the downlink data that came right down and were recorded at the big deep space network dishes on the ground. These tapes were ones that were taken right after the NTSC conversion scan. And he still sold them for $1.8 million. But get this, the fact that NASA not only lost, I don't want to bash NASA too much here, but it's common knowledge they lost and apparently sold those other tapes, the downlink tapes, and they were written over. But then they made another mistake and sold off these next generation tapes. Yeah, I must have a note here. That was it. Okay, so this fellow, well, this is just a nod to the fathers out there. It was his dad who noticed those 3 tapes out of the 1,100 tapes that he bought, that these had Apollo 11 EVA on them, and his dad said, maybe you ought to keep those. So I don't know if this fellow gave his dad any part of the haul on that. There they are. They're 2-inch Ampex tapes. Just a couple other pieces of little details that I think are just kind of interesting is he hauled them around for 43 years. He had held on to these tapes for 43 years. And he only found out when he went on vacation with a NASA friend who said, we're looking for these lost NASA tapes. So they easily could have gotten lost, if not for these coincidences. All right, that means I have a note here. Okay, I've already mentioned that. Let's move on. Okay, let's skip over that. Okay, another thing about Flagstaff history and Apollo, and I'll get back to my original topic eventually, if you'll pardon me. This is what was called the geology back room down in Houston. It was literally next to mission control, the mission operations control room, where Gene Kranz and Steve Bales and all those famous guys were running the mission. So next door you had a group of geologists. The guy, let's see here, get the pointer. This fellow here, Gordon Swan, Flagstaff. I don't know if anybody here knew him. This is Jim Lovell of Apollo 13, sadly just passed away. Now, I bring this up because I need to say that, tell you, if you don't already know, Gene Shoemaker was the principal investigator of Apollos 11, 12, and 13. This fellow here, Gordon Swan, was principal investigator for Apollos 14 and 15. Gordon was hired by Gene Shoemaker. Okay. The guy who was the PI on Apollos 16 and 17 was this fellow, Bill Mulberger. Bill was not only hired by Gene, but he was a classmate of Gene's at Caltech. So basically, Gene Shoemaker and Flagstaff basically had control of the entire Apollo geology. And that's a whole nother story. I could give several talks on that. Okay, this is something most everybody's seen, if not at the time, since then, called the Trench Mission Operations Control Room. And the scene you typically saw was looking over at this screen, see the moonwalk. Rarely you'll see this screen over here, which is a lot different. See a hand here on what looks like maybe a map. I'll show you what that is. So over in the geology back room, they had a camera overhead pointing down this fellow's hand. I used to work for this guy for a while. And he's got basically a map of the lunar module here. This was for Apollo 11, so they weren't going very far. And they were basically mapping out where they were placing instruments and where they were picking up rocks. There's another view of the back room from a BBC special. Okay, why have I got this here? Let's see. So Gordon Swan over here, Jim Lovell on the right. So now I get to the part about a piece of local, it's kind of a secret. Most people don't know about Flagstaff. Gordon Swan over there on the left, being the PI on Apollo 15. He was charged with doing a geological survey report summarizing what they learned from Apollo 15. Well, he didn't get it completed. So another fellow here in Flagstaff, Paul Spudis, was given the task. Paul came to me and said, Rich, can you go and get me a set of the Apollo 15 tapes so I can kind of watch along while I'm doing the geology report kind of thing? Well, that's when we discovered. I called NASA. NASA said, we don't have the video anymore, but we can send you some 16mm film. Well, it turns out we had in our data facility up there a bunch of half-inch reel-to-reel videotapes. So, okay, so we tried to find the equipment. Well, guess what? they surplused. They had 3 of these machines, they surplused them all. Luckily, we were able to find the warehouse did keep records. We were able to find out, track down 2 of them, one of which fortunately worked. And this is from a NASA film of the recorder actually being used in the back room by the geologist. So this is another case of what Dennis Wingo of the LOIRP calls technoarchaeology. You know, we've got some data, but we hadn't thought it through, and we got rid of the equipment. So as I say, we were able to track down a couple of these. And here's a rather poor quality picture, but on the right is after we had recovered the machine. It had some electronics problems, only showed us half a picture. We were able to fix that. Even Sony wouldn't touch this thing. They manufactured it, but because it was so old, they wouldn't touch it here in the late 80s. Oh, the other thing I want to tell you about this is that because they did not want to use the old original tapes that we had or the machine, he said, can we I forgot who came up with the idea, but the idea was to transfer it to what was then the industry standard, which was called U-matic. It was a 3/4 inch format. And the reason we wanted to transfer it is we don't want to use your original equipment. It's old enough as it is, and you don't want to damage tapes. But the problem was the electronics were starting to fail. The longer it ran, the worse the picture got. In order to deal with that, I spent about 80 hours in a walk-in cooler transferring the films. So some of the things that you don't hear about, I won't bore you with that one. But in short, while NASA was catching flack in like 2006 and 2019, the truth is, I found out, the National Space Science Data Center's 1977 catalog of lunar mission data mentions only kinescopes. So it suggests to me that the videos were already gone by then. And I don't know if you caught earlier this fellow who sold the tapes that he had bought for $1.8 million. He bought those in 1976. So it kind of fits the pattern. Just a little bit of history about that story. Okay, so now let me get finally back to the topic of tonight's talk. What if we had the original downlink data tapes from the Apollo TV? So you'll recognize this from the lunar orbiter schematic earlier. Only in this case, let's replace the onboard film in orbit with the Apollo slow scan camera on the moon. It transmits from the LEM down to the ground station. Receiver picks it up, records that data. I explained the slow scan conversion. So you follow this path, slow scan conversion. You take a picture of it, film, 16mm film off of a TV screen, and that's what we got to see. What if we could go from here straight over and look at that directly? Now, if we did come over directly from the telemetry data over to create a new video from that original first generation data, we'd still have that 10 frames per second slow scan problem. But there's a process called tweening, creating frames in between missing frames. So you could do that easily, create one missing frame, and that'd get you up to 20 frames per second, which is, like I said, equivalent to the old 8mm films. You could probably go to 30 with today's artificial intelligence processing, but we'll never know. Okay, so we can only imagine what the improved images could have looked like. I forgot to mention that Westinghouse did an excellent job building that Apollo TV camera, and it really gave a much better picture than we saw. Okay, so remember the LOIRP people, the quote saying, well, we're lucky there were still people alive that we could go to and help us restore the equipment and get the data back. So let me talk a little bit about other ways of getting, old data and getting more out of old data. So one of the things is that, yes, when people die, you lose an awful lot of information. I started an oral history project back in the late 90s. This is Elliot Morris. I mentioned him early on in relation to the Surveyor project. Early on, the first mapping of the moon, preparing for the Apollo project, was mapping the moon sitting in a telescope. Here, Elliot is describing the telescope that he helped get built in Flagstaff. It's out on Anderson Mesa right now. That's me right there. All right, so I've already mentioned about Elliot. We interviewed Hal Stevens. Hal was a geologist. He used to live in our neighborhood. He went from an interesting path. I won't take too much time to tell it, but basically he he spent a lot of time recording this history of the Apollo training and the development of the Apollo procedures here in Flagstaff. So we interviewed him. A couple of shots of Gene Shoemaker that we interviewed. We got about 5.5 hours of interviews with him. We were going to interview him after he got back from his annual trip to Australia. Sadly, he died. Car crash then. This is Gordon Swan. We interviewed him, PI on Apollos 14 and 15. And including others, we interviewed Jack Schmidt. Okay, so just to say that new knowledge can sometimes come just from saving personal knowledge for later use. And using the harvesting data as an analogy, kind of think of this as seed banking. We're putting these things away for later discovery. Okay, I'm getting close to the end here. Another thing, say, is old AV materials, audiovisual materials. I pulled these out of a dumpster. These were being thrown away. 2-inch, what I thought were a standard, what in the day was 2-inch Ampex format tapes. And again, we're going back to this, what Dennis Wingo called the technoarchaeology problems. See by the label on the tape down here, it says field test Hopi Buttes, moonshot phase 3, October, November 66. Based on that date, what I think was on there was something like this. These were taken from some 16mm films that were also saved, since lost, I understand. Field test in the Hopi Buttes, you see a mock-up of the lunar module. They go out there in shirt sleeve usually and rehearse what they were going to do in terms of the procedures for Apollo. So I mentioned those are what I think are videotapes. You can see a video camera on top of this LEM mock-up. It looks like it might have been out to Benito lava flow. Another close-up of the camera. Let's point this out. So there's a camera on top of this. This is stereo periscope. Original idea was to have one man go out and walk on the lunar surface, another man stay in the LEM, maybe even have a microscope, be mapping out where he was going. He could follow him with his stereo microscope, and he could control the video camera with a little box there. Didn't happen that way, but as it turns out, they did incorporate the remote controlled camera idea on the later missions, the J missions, Apollo 15 and thereafter. This is the TV camera mounted on the lunar rover as they're traveling between the two stations. Well, just as I was about to send these tapes off to get them transferred over to something digitized, I found out that they were not the standard Ampex, that they were this odd helical scan format. Well, guess what? Nobody anywhere has one of these machines. Checking around with, I don't know, about a dozen people around the country, some of the top people in their field, I found out it was recorded on this type of machine, a Sony PV100 model. Turns out they were used on airplanes back in the day to show in-flight movies. Yeah. And once I knew what they were recorded on, I went back to these old films that we'd saved and restored, and you can see it actually in operation, that we can verify it was that indeed that model machine that it was recorded on. So now that I knew what kind of machine I was looking for, I was trying to find somebody that had one. And I've checked the Smithsonian, I've checked all of the top people in the country. Nobody has one of these machines. I've tracked one down in Belgium, and hoping they'll work with us. I haven't followed up on that. Okay, real quickly, again, what time? 3 minutes, I think I can do. Okay, so there were 16mm films I mentioned. I found some, these are some film cans. At the top, you see what kind of terrible condition is. I mentioned early on, a fellow Rick Balch, a videographer down in Sedona. That's him here. And he was instrumental in helping to save those films. He cleaned, I think it was 16 hours of film, and it's equivalent of 6.5 miles of 16mm film. Cleaned it by hand before he transferred it. He filmed it. And here's some of the title screens from a number of those films that we saved. Basically, I already talked about that. Okay, here's a couple of still frames from a couple of those films. Real quick, talk about the fact that this is out at Cedar Lake, just outside of town. Just got put on the National Register of Historic Places about 5-6 years ago. Some of the things you can do with say, 16mm film are kind of interesting. If the person filming is doing a panorama, you can take those still frames and stitch them together. And I made this real wide panorama of Cinder Lake from that. Another thing you can do is you can sometimes get stereo pairs. They just move the camera slightly, even sometimes turning to do a pan, you can get stereo pairs. Another interesting thing is even if the camera's pointed at one point for a while, you can capture a number of frames. What you can do, again, is add those frames together in the computer. And again, you improve the signal to noise ratio. And this has actually been done with one of the Mars rovers. You can get a much more detailed picture. Now, those aren't really scientific, but they're just kind of interesting things you can do with data. Audio, they had some tapes of the audio of the training exercises they did. I need to follow up on that problem. Last thing I'll probably talk to you about before we run out of time is when the astronauts, to free up their hands, their camera was mounted on their chest. And so everything they did, they had to use their whole body to point. So if they were taking a panorama, they had to get it just right so they didn't get all sky or all land. They're doing a sample, they had to be able to point. So they had to practice that. And they did that out here at Cinder Lake. This is a picture of this mosaic, two-frame mosaic on the bottom. It was taken by Alan Bean of Apollo, later walked on the moon on Apollo 12. Did a panorama. I found these out at the National Archives. And what I find exciting about this is this upper picture. At one point, he turned and he took a picture of Gene Shoemaker out there. So these are the kind of things you can find and I think are important to save. Real quickly, up there at the USGS, they have what I estimated. I did a spreadsheet. I estimate 5,000 to 10,000 still photos that are up there. I know they started digitizing them just a number of years ago, just before COVID. I don't know what happened. Last thing, paper documents, maps, internal documentation, graphs, and so forth. I won't tell this story. We're running out of time, but there's things like gray literature, monthly reports. That's just a table of reports that I can't find. Same thing with annual progress reports, memoranda, just memos to people. Put this one in because George Ulrich was a neighbor and he also got me into home brewing. Organizational charts are really handy. Newspaper articles can be handy. Now here's a case where I was told that the Arizona Daily Sun, their archives burned many years ago. But we're able to get some of them because some people cut them out and kept them in scrapbooks. So there is some data there. And I'll tell you, there's lots of good quotes and information to be found sometimes. Here's a really an example which kind of reminds me of the Dead Sea Scrolls. The quality is so bad, I had to really do a lot of processing and read carefully to create some readable text. Okay, in summary, there's newly discovered or newly created data. There's newly recovered data. There's new ways of looking at processing or analyzing old data. And then there's, just as I just covered in the last part of the talk, basically not losing the data, preserving it. So that's my talk. Thank you for coming. And thanks to our sponsors. If you would please consider filling out the survey. Hope I didn't run over too much.